Hi there, my name is Cameron Anderson, and I'm a graduate student working at the Maple Lab at McMaster University. In this presentation, I explored differences in the cue use of two historically important composers to identify expressive patterns in their music. Evidence from empirical musicology studies suggests the generalized cue relationships that researchers often take for granted may be limited to specific historic contexts. Recent findings point to notable differences in the cue relationships of music composed between the 1600s and 1900s, from their rhythmic patterns to their cadential structures. Mode's relationship with loudness and timing saw great shifts in the Romantic era, posing difficulties for studies assuming that pieces composed in a minor key tend to be softer and slower than pieces composed in a major key. Previously, researchers Caitlin Horn and David Huron performed cluster analyses to reveal historic differences in a large corpus of music composed between 1750 and 1900. Here I apply this technique, focusing on the works of only two composers, to reveal how differences in their musical choices create expressive contrast. My analysis focuses on four cues in particular: musical timing, measured in attacks per second; pitch height, a relative measure of how high or low music is; RMS, a measure of the average dynamic level of a piece; and mode, which here we define as whether a piece is in a major or minor key. The corpora I explore are Johann Sebastian Bach's The Well-Tempered Clavier and Frédéric Chopin's Preludes, each containing a piece in every major and minor key. The timing and RMS information come from recorded performances of Pietro de Maria and Vladimir Ashkenazy, and are used in complementary perceptual experiments. Cluster analysis is a machine learning technique which blindly groups observations based on similarities in their underlying data structure. In musical applications, the analysis can reveal expressive similarities between pieces without revealing how or why they're similar. Instead, the researcher can ascertain the meaning behind the relationships through interpretation or applying complementary algorithms. The exploratory nature of cluster analysis provides a robust way of exploring high-level concepts such as musical expression and provides insight into composers' musical choices. In the present analysis, I use 5 clusters to separate each composer's music according to expressive similarities. Before coming to the cluster analysis findings, we'll orient ourselves to a scatter plot which I'll use to reveal the results. The three-dimensional plot you see here will depict the scaled values of pitch, RMS, and attack rate on the X, Y, and Z axes respectively. The modality of each piece is represented by its uppercase or lowercase key signature. Each piece is color-coded based on the cluster it appears in, with Bach represented by shades of red and Chopin blue. I use a sequential color scheme to distinguish the 5 clusters from each composer's cluster analysis. Already we can see some notable differences in cue use. Note that no cluster here contains pieces from both modalities. As such, we can subset the data and summarize each cluster based on its mean pitch, timing, and RMS values. I denote the number of pieces in each cluster using parentheses. For major pieces, 2 distinct clusters emerge for each composer. While clusters of Chopin and Bach's major pieces reach approximately the same maximum pitch level, one of Chopin's pieces is characterized by very low pitches. As we rotate the graph, we'll see along the horizontal axis that Chopin's major pieces are somewhat slower than Bach's. Along the vertical axis, we also see that Chopin's major pieces are softer than Bach's. Comparing minor clusters reveals 3 subgroups for each composer. Here again we see Chopin can use lower pitches to create greater expressive contrast than Bach. Rotating the plot so that timing is depicted on the horizontal axis shows his minor pieces are also distinguished more frequently by a fast attack rate. Along the y-axis, we also see his minor pieces are generally louder than Bach's. The present analysis provides some support for a changing role in cue relationships across history. The louder, faster minor pieces in Chopin's analysis are consistent with a changing expressive role of the minor mode in the Romantic era. Although this finding is intriguing, it must be taken with a grain of salt, as the RMS and attack rate values come from recorded performances on modern instruments. The future of this project will explore the perceptual implications of these changing musical relationships by comparing these acoustic patterns to patterns in participants' emotion ratings in perceptual experiments. If you'd like to learn more about the perceptual experiments we're conducting, you can view my labmate Ben Kelly's presentation. If you have any questions about this project, you can contact me at my email address here or reach us at our Twitter handles here. Thank you very much for listening.